So if you were doing y squared minus 49, then factorising it would be y plus 7, y minus 7. And you must message me if you're not familiar with this, because I don't know how much of this work you've done before. So what we've really got there is the square root of 49 is what gives us this and this. And basically the square root of y squared is what gives us this and this. So we could actually do 2y plus 7 and 2y minus 7. And if I was multiplying this out to check my answer, I would use the box method. 2y and minus 7, so that's 4y squared, yeah, 14y minus 14y and minus 49. So these two actually cancel each other out, and you're left with 4y minus 49. So this is the answer factorised. Okay, there is an easier way of doing this than just doing the 40, writing down 42, 84, 120, 240 until you get the same answer. There is an easier way to do it, and it involves prime factor decomposition. So I'm going to decompose 42 into its prime factors. So that's 2 and 21. Numbers that multiply to give 42, numbers that multiply to give 21 is 3 and 7. So 42 is made up of 2 times 3 times 7. So I'm going to do prime factor decomposition of 120. So 12 and 10. That'd be 2, 2 and 6, 2 and 3, 2 and 5. There we go. So this decomposes to 2 times 2 times 3 times 2 times 5. I now use Venn diagrams. So we've got 42 here and 120 here. And what we're looking for is the numbers that they have in common, first of all. So they've got a 2 and a 3 in common. So 2 and a 3 in common. And then 42 has got another 7. And 120 has got a 2 and a 2 and a 5. So this number in the middle here is actually the highest common factor. But what we're after is the lowest common multiple, the lowest number that appears in both their times tables. And that's going to be all of that. So if I just go back one there, let's use yellow. So that's going to be the 7, 2, 3, 2, 2 and 5. So literally, if I multiply these numbers together, so 2 times 2 times 2 times 3 times 5 times 7, that should give me the lowest common multiple, which if you work it out is 840, and I think that works out to be 14 minutes. And that's quite a long time, so when you said you've gone for ages and haven't found it, it's because the method of just writing out the times tables, it works, but it's very long-winded in this case. So the bearing of z from x is basically going round to there, it's that angle. But what we want to find out first is this angle, and then all we need to do is add that 180 to it. So depends on whether or not you can do trigonometry. So if you message me, either you try trig and see if you can do it on a piece of paper and upload a photo, or what you could do is message me and I'm happy to go through that question again fully.